Spacetime is a mathematical model that combines space and time into a single interwoven continuum. Spacetime is not a static concept, it is constantly in flux. The fabric of spacetime can be warped and stretched by the presence of matter and energy. This warping and stretching is what we experience as gravity. In the late 1800s, physicists began to develop the theory of spacetime in earnest. One of the key figures in this effort was Albert Einstein. In his theory of general relativity, Einstein showed that gravity is not a force between masses, as had been previously thought. Instead, gravity is a curvature of spacetime. The presence of mass or energy warps the fabric of spacetime, much like a heavy object warps a trampoline. The bigger the mass or energy, the more pronounced the warp. The warping of spacetime explains many of the strange phenomena associated with gravity, such as why objects fall at the same rate regardless of their mass. It also explains why gravity is the only force that can act over long distances. In the early 20th century, physicists began to think about spacetime in a different way. Instead of thinking of spacetime as a smooth fabric, they began to think of it as a series of discrete units, or quanta. This new understanding of spacetime led to the development of quantum mechanics, the branch of physics that governs the behavior of subatomic particles. Quantum mechanics is based on the idea that spacetime is not smooth, but is instead made up of tiny units of space and time. These units are so small that they cannot be observed directly. However, their presence can be inferred from the behavior of subatomic particles. The behavior of subatomic particles is often bizarre and seemingly random. However, this behavior makes sense if spacetime is made up of discrete units. The quantum nature of spacetime explains many of the strange and seemingly random behaviors of subatomic particles. It also explains the strange behavior of particles in a gravitational field. In the late 20th century, physicists began to think about spacetime in a third way. Instead of thinking of spacetime as a smooth fabric or as a series of discrete units, they began to think of it as a collection of infinitely many points. This new understanding of spacetime is called string theory. String theory is based on the idea that spacetime is made up of tiny vibrating strings. These strings are so small that they cannot be observed directly. However, their presence can be inferred from the behavior of subatomic particles. The behavior of subatomic particles is often bizarre and seemingly random. However, this behavior makes sense if spacetime is made up of vibrating strings. String theory is the most promising candidate for a theory of everything. A theory of everything is a theory that explains all of the known forces and particles in the universe. String theory is the only known theory that has the potential to be a theory of everything. String theory is a very complex theory. It is not yet fully developed. However, it has already made some predictions that have been verified by experiments. One of the most important predictions of string theory is the existence of extra dimensions of space. These extra dimensions are too small to be observed directly. However, their presence can be inferred from the behavior of subatomic particles. The NCE of extra dimensions has been verified by experiments. The most famous of these experiments is the Large Hadron Collider, which is a particle accelerator that is used to collide subatomic particles. The Large Hadron Collider has confirmed the existence of extra dimensions of space. This confirmation is a major victory for string theory. String theory is the most promising candidate for a theory of everything. It is a very complex theory that is not yet fully developed. However, it has already made some important predictions that have been verified by experiments. The development of string theory is ongoing. It is an active area of research for physicists all over the world.